Lesson number 97 is about angles and triangles, the Pythagorean theorem, and Pythagorean triples. Now whenever we look at a right triangle because we've got a 90-degree angle, the two sides that touch on the right triangle that meet at 90 degrees are called legs. And then the diagonal side here, that's opposite of our 90-degree angle, that's called the hypotenuse. Now, there's a relationship between the two legs and the hypotenuse in any of these right triangles. That relationship is called the Pythagorean theorem. And the Pythagorean theorem says that, well, a leg squared plus a leg squared is going to equal the hypotenuse squared. And we're going to put HYP for hypotenuse. Now when you see this written out, it's usually not written as a leg squared plus the leg squared equals the hypotenuse squared. Usually we use values or variables for this instead. So let's call our short leg A, our long leg B, and our hypotenuse C. And if we write it out like this, we're going to get A squared plus B squared is always going to equal C squared. And what this means, if we take the square of our short side, add the square of our second shortest side, or leg, it's going to be equal to the square of our hypotenuse, or side C. Now let's take this A squared plus B squared equals C squared and solve a few problems with it about right triangles. Given the triangle with the following side lengths, use the Pythagorean theorem to solve for the missing side length. So what we need here is C. And C is going to be our hypotenuse because it's the diagonal side that's opposite to our right angle. So in this one, we know A squared plus B squared equals C squared. A is always our short side, so this time A is over here. B is our other leg. And we're going to say A squared plus B squared equals C squared. So A value is 4. So we're going to get 4 squared plus our B value is 5 is all going to be equal to C squared. Well, let's go through the math. 4 squared, that's going to be 16. 5 squared is 25. And that's all going to be equal to C squared. Well, 16 plus 25 equals 41. So we get 41 is equal to C squared. Now if we want to know what C is, we've got to take the square root of both sides, because the square root undoes the square. So C is going to equal the square root of 41. Now the square root of 41, that can't be simplified any further, so we've got our answer. C equals the square root of 41. Now when we look at this carefully, A is our short side, B is always our middle length side, and C is always our longest. Now the square root of 41, you could calculate with that with a calculator, or you could say it's going to be between 6 and 7, and it's between 6 and 7, well, maybe it's like 6.5 approximately. That's our longest side, and that makes sense because A is short, B is middle, and C is our longest side. So we've got our final answer. C is between 6 and 7. We're not going to round to a decimal. We're going to leave our answer as the square root of 41. Let's look at another problem. Here we have to solve for the same thing. And in this one, if we look at it, our right angle has been rotated a little bit, or our triangle has been rotated, and our right angle is now here. So we're still solving for side C, our hypotenuse, which is diagonal to the right angle. So we get A squared plus B squared equals C squared. We've got our A value of 8, our B value of 12, short, middle, longest, and let's solve. So in this one, 8 squared plus 12 squared will equal C squared. 8 squared is 64. 12 squared is going to give us 144, and that's all going to equal C squared. Now when we simplify this, we're going to get 208 equals C squared. Then we'll take the square root of both sides to undo our square. So the square root of 208 will equal C. Now we need to think about if we can simplify this. So let's try. Square root of 208, well, that can be broken down into the square root of 104 times the square root of 2. Square root of 104, that can be broken down into the square root of 52 times the square root of 2 times the square root of 2. Now this one's nice because the square root of 2 times the square root of 2 is just going to be 2. Or we could rewrite this. We could rewrite this as 52 is, well, that's going to be the square root of 26 times the square root of 2. And the square root of 2 times 2 here is the square root of 4. And we know the square root of 4 is 2. So as we continue to simplify this, we're going to get 2 times the square root of 26 times the square root of 2. Now let's break it down more. So the square root of 26 is going to be 2 times the square root of 13 times the square root of 2 times the square root of 2. We know the square root of 2 times the square root of 2 is 2, so we're going to multiply 2 times 2 and get 4 times the square root of 13. And there we go. We've got our final answer. C is equal to 4 times the square root of 13. We've got to make sure that we fully simplify these radical expressions just like we simplify 5/10 equals 1/2. Let's look at another one. This one's a little bit different. This triangle, well, we have a side length of 5, then we've got a missing side length, let's call this B, and then we have C, our hypotenuse, which is the square root of 41. This time when we use a squared plus b squared equals c squared, we have our a value of 5, so we're going to get 5 squared plus our b value squared equals the square root of 41 squared. And then we can go ahead and solve this. Let's separate our work here. Now we need to simplify. 5 squared, that's 25. So we get 25 plus b squared is equal to the square root of 41 squared. Well, whenever you take a square root and square it, you're just going to be left with that number. So we get 41. Now, in order to find b squared, let's subtract 25 on both sides. So minus 25 and minus 25. And then we can go ahead and find our final answer. B squared is going to have to equal 16. Well, what number squared equals 16? B is going to equal plus or minus the square root of 16. Remember, when we have square roots, we have the positive and negative version. So B must be equal to plus or minus 4. But in this problem, since we're talking about a distance, we have to have the positive version. So B is going to equal 4. So we've got it. B is equal to 4. Now in this one, we said A was the short side, but it ended up being the medium side, or the middle side. And A and B, they can be interchanged because they're both on the same side of the variable, separated by addition. Remember, order of addition doesn't matter. But C, our hypotenuse, will always be our longest side length. Alright, the last part of our lesson is about Pythagorean triples. And these are triangles that will have these side lengths always in this proportion. If we have 3 as our short side and 4 as our middle side, 5 will always be our hypotenuse. If we have 8 as our short side and 15 as our other leg, our b value, then our hypotenuse will always be 17. If we have 5 as our short side A, 12 as our medium side B, our hypotenuse will always be 13. Now get these in your notes. Get these in your notes because these are ones we'll see commonly. And if you can have this to refer to or have this committed to memory, it will help you solve problems much more quickly than having to go through a squared plus b squared equals c squared every single time. You can always do that, but this is going to be quicker if you have it in your notes or have it in your memory. Our lesson practice? Well, our lesson practice page is not listed, but it's on page 410. So we'll get that in here, page 410 for our lesson practice. Make sure you've got your notes complete, and I'll see you during our next class.